Good morning, everybody, and I would also like to say thank you for coming, thank you for interest. I'm really impressed by this amount of people, and thank you very much, the Frog folks, for inviting me, for organizing this event. Really appreciate it. And yes, today I'm going to talk about robotics in general, and the title for this presentation I decided to make is that proliferation of robotics is an opportunity for creators, because I was assuming that most of you here are from the creative side, and I really believe that it's a big topic and a big opportunity for creators. And just to confirm this statement, let me give you an example. Here you can see this picture, just several examples with pictures of the robotics company with their names. It's not really important to read all of them, but they all have something in common. And in particular, all this company, and actually a couple more of them, was bought by Google last year. And if you are not in robotics domain, you might recognize the names, for example, the Boston Dynamics. This is really kind of rock star in one of them. They are doing also military robots, also this kind of scary big dog robots and so on. And you can imagine how much money I actually invested in this company. And Google was doing it last year. They bought all of them last year. And just even this fact to me is a clear sign that something big is going on, that this topic going to be even bigger, and that's why I think it's relevant and it's worth to take a look on it, because chances are that in your work or as a hobby, you will be doing something with robotics in the future or in the near future. And we, as a team of robotics enthusiasts, we will also like to build our robots, but unfortunately, not this one. Not that complicated, this one. This is, by the way, what you see here, it's a Curiosity rover on the Mars, and this is, in fact, the first robotic selfie on the Mars I'm aware of. So this is actually the picture taken from the second camera of the robot, just to check that its state. And in our case, we actually decide to build something a little bit not that complicated, and our motivation was the fact that we've seen several times, especially in the university domain, that a lot of researchers are, because there is a demand, because something happens in the robotic world, there are also a lot of research going on. For example, there are a lot of people doing research in the area of new navigation algorithms, new control algorithms, doing this complicated math and theory behind it. But at a certain point of time, they reach the moment where they would like to test whether it works. And then in this case, they need something, the physical object, the physical platform or vehicle to try the algorithms, to adjust, to adopt, and to prove them. And in fact, on the market, there is a kind of gap between very cheap devices, between like simple Lego robots, which are fun to play with, but they are not capable enough to run this high-end, highly complex computational algorithms and so on. And at the opposite side, there are actually platforms which are very well capable for doing all this stuff, but they are really expensive. And there is really almost nothing in between. And this is where we think, okay, we can try to offer something exactly in this area. And this was our motivation to build this vehicle you can see here. I would like to talk a little bit more details. Just to give you a feeling about What are the kind of difficulties? Why it's difficult? And in fact, it's actually very easy to underestimate the complexity to build this kind of vehicles. Let me give you just a couple of examples. What can be difficult? So the first one I usually like to talk about is even driving straight forward. If you just take a very simple vehicle like this one and try to drive straight forward, it wouldn't work if you do it in a naive way, like apply same voltage to the different motors and expect that it would drive straight forward. It wouldn't, because motors are physically different. There is different friction, and one would rotate a little bit faster, and that's why you won't be able to drive straight forward. To achieve this behavior, you need actually then feedback from the motors. You need to know how far they're rotating, what the distance they traverse it, and then it starts to get complicated. And the second example is if you're trying to do video streaming, live video streaming over the internet for the kind of telepresence scenario, and trying to do it really over the internet, then the constant changes in the available bandwidth, communication bandwidth, will very negatively influence the quality of the video. And based on our experience, our first implementation, I was trying to drive through the door in my room and didn't manage to do it really over the internet because the frame rate is constantly changed, and I was constantly bumping on the wall. And that's why usually the so-called adaptive video streaming is required, where you need to constantly observe the available bandwidth and try to keep the frame rate, because this is the critical factor for the comfortable driving experience. And this is where the complexity is coming from. And as I said, it's very easy to underestimate, and especially for the folks who are doing research in the higher level control algorithms like navigation, localization. These topics are actually not really interesting. They want to keep focusing on their research and not deviating for kind of half a year to these topics which are not interesting from the research point of view. And this is the kind of infrastructure and support and software we are offering to let them jumpstart to provide this as a basic for their research. And as a result of our efforts, this is what we've made. Here's the one example. There are several modifications of our vehicle. And it might look a little bit like a toy, but in fact, it's really packed with different kinds of sensors. For example, we have 2 cameras mounted on the rotated head. We also have the compass, digital compass. We have 4 ultrasonic rangefinders. We have also connectivity options, like you can use Wi-Fi or UMTS to drive around, and there is also, it's important thing, there is also pretty powerful onboard computer. This is, by the way, also open hardware, very popular platform called BeagleBoard. We have it inside, and we also have a GPS receiver here in this mast. We have a GPS receiver, we have compass. So this is the kind of standard set of what is necessary for really advanced control algorithms. But in fact, we did not start right from this point. There is also a long history behind this development. And I just want to say a couple of words about the history. So at year 2009, we started it was a pure hobby project. We just rebuilt a standard radio RC car, radio-controlled car. And then we made a next step and use a kind of this one. And at this point in time, we decide to experiment a little bit with stereo vision. So we mount 2 cameras and actually build the very first user interface application where you can control it remotely. This is, by the way, if you didn't know what it is, this is supposed to be a steering wheel, and this is a kind of Tahoe here. But this was the very first version. And the picture here, you can see it's not an actually distorted picture. It's in fact so-called anaglyph image for stereo vision. So if you put this standard green cyan glasses, you will be able to see the stereo picture from this camera. But it's everything good and nice, and actually electronic was in this vehicle was almost exactly the same as in this one. But if we would ask ourselves questions, it's good, nice and good, but is it impressive? And the answer and the feedback we've got from the different presentation was not really, so not really impressive. And at this moment, we actually decide that we need a designer, we need someone who can help us to build a nice looking vehicle and address some design challenges we have. And when I say we're actually a small team, 2 of us are here, and then we were looking for designer, and we post a call for help in the different 3D modeling communities across the internet. And since we are doing this everything as an open source project, we were trying to invite and attract the people to participate and to help us. And this is also kind of interesting situation, because this is how the team looks like after the response we've got. So the third guy, this is actually his avatar. And the point why I did not place the photo, his photo here, because we did not know each other, in fact. We are solely communicate and actually collaborate over the internet. At the beginning, it was feeling like a little bit strange. In fact, he's from Kostroma in Russia, so we are speaking the same language, but we did not ever have a voice chat with him. We communicate per email, and at the beginning it was feeling like a little bit strange, but now I'm quite happy because he actually requests all the technical stuff, like where should be the mounting points be, for example, for body. Then he disappear for a couple of weeks, and then come back and say, here's the model, just try to print it. At the beginning it was like, but now I think this is actually perfect. He does not distract us from our work. He get information he needs and then come back with an actually very, very good solution. So what I want also, we are quite happy right now. But this situation should also illustrate how easy it's currently using the internet, all these possibilities we have to collaborate. And collaboration is an important point here. And after his name is actually Nikolai, after he joined our team, he started modeling very different types of bodies for this vehicle to improve this horrible situation we have in the past. And he was also working on the user interface. And what you can see here is just an example. He's using mainly the known open source 3D modeling tools called Blender. I assume that most of you have heard about it. And what you can see here is just yet another modification of the vehicle. For example, this is the one where you can mount the Kinect sensor on top of it, which is a very popular sensor in the robotics world. And here, let me give you just a couple of examples of his works. What he was suggesting for us, and we were iterating and deciding which one we will take. So there is also the wheeled version of this vehicle, or you can see this one would be possible, or this one where we put our focus on the physical accessibility of all the electronics which is inside, because with this model it's not that easy to get access to the electronics, which might make debugging a little bit more complicated. But all these things are possible because of the application of 3D printing technologies. This is what we're using very extensively. And in fact, all you can see here, most parts of the robot are 3D printed on this printer. You also can see here. And if you like, you can just pass several parts of it we have here and just to touch them to see how it feels. And actually, nice thing about the 3D, and this is how the complete kit looks like. So actually, you can print, you can build electronics, all the CID files, all the schematics, all the software we need is everything open, and I will provide the link later on. So it's all everything open. And the nice thing about it is that it's highly customizable. And since we define our target audience for this project as the researchers who are doing new stuff, our experience is it's almost never possible to make something which fits their needs. They always want to adjust it for their particular project. And this is where this openness, the idea of open source and application of the 3D technology really can be very useful, because if they want to play the different types of sensors, no problem, just take a model, make additional mounting places, additional holes, and put your new sensors. And this is what the community was really appreciating, and was kind of important feature. And in fact, uh, there is also interesting consequence of the availability of this kind of technologies is that it's now not that complicated to build the vehicles, for example, robotics vehicles like this or similar or whatever robotics vehicles you like. It's not that difficult. And the message I would like to make here, you can also do it here, do it on your own. You can build it with us. You can use this kit, for example, as a basic, as the beginning point, and then adapt it for your needs. Or you can learn and study what we have done so far and use it to build your own project. But it's becoming increasingly less complicated to manufacture something like this even at home, because this 3D printer, from the price, it's in a notebook domain. I guess it's about it's a little bit more than 1,000 euros, so it's something like a notebook. So a lot of people can afford it, and it makes it possible to build something like this. So that's why my statement here, you can also build it, and you can start with something which is already available and customize it. But in fact, all the ingredients, and I call it as ingredients, is a parts which are the big topic domains which are necessary to build something like this. It's actually here. This is my statement. So the first class here is 4 cloud sites which represents all important ingredients. The first one is that solid software and hardware foundation. So as a builder, as a creator, nowadays, there is no need to start from the 0 level. There are a lot of libraries, from software libraries. There are a lot of instructions and tutorials how to deal with the software. It's all open source, and it's really easy to start using this as a base for your project. Also important things as a manufacturer. Manufacturing is becoming more and more affordable. And if you have a more ambitious goals, it might not be, you might not have all the required equipment at home, but the maker movement makes it easy to get access to this kind of equipment. And here I would like particularly emphasize on the Munich Maker Labs, and in fact there are 2 guys here from the Munich Maker Labs right now who has all the equipment. They have laser cutters, they have 3D printers, they have everything you need to build this or even much more complicated projects. So just come to there and see if you can. You will definitely be able to use the equipment and this opportunity. So it's also here. It's here in Munich. There are at least 3 maker spaces I'm aware of. Maybe there are more. Another interesting part, and this is a really important part, if you try to define the more ambitious goals, not just like driving around and avoiding obstacles, but if you try to go more into the autonomous behavior, really complicated behavior, you will need a knowledge. And recently, or what meant recently, it's since about 2 years, I guess, already, there is an initiative on internet which is called MOOC, which stands for massive open online courses. This is where the top universities, really like Stanford, MIT, offering the video courses made by top professors in this domain, and in particular in robotics domain. There are excellent courses which explain the theory, the math, the algorithms to do really complicated stuff like autonomous navigation, localization, mapping, all this dynamic stuff. You have free, and this is everything for free, and there are different companies doing it, or these spin-offs from these universities. You can get this knowledge, and it's already here. And even if you still don't have some need to communicate, to meet in person, there are also, and this is a very important part, the communities are there. And here I would like to make also a little bit of advertisement for the meetup I'm organizing. It's we call it Munich Robotics Enthusiast Meetup, and this is the kind we are meeting like once a month, trying to present the project. I'm trying to also to invite usually this kind of interesting speakers, and there is a time to ask the questions, to try to get help from the people who have already made something and built something, and just to chat and exchange experience. So I'm if you search for Munich Robotics Enthusiast, you will definitely find it on a Meetup.com website. And at the beginning, I said that here that the proliferation of robotics is an opportunity for creators. And as a what the lessons we learned while building this kind of vehicles, I was trying to summarize it here. So the first point is that mechanics, from the mechanical point of view, the robotics vehicle are approaching the level to solve also real-life problems, so really complicated problems, like making a cup of coffee using this mechanical arm. It's not an easy task, but mechanical parts are almost there. However, onboard computers still not, but this is my personal opinion, still not powerful enough to run really complicated advanced algorithms. And that's why what is becoming currently increasingly popular is, and it's really kind of hype nowadays, it's so-called cloud robotics. And the idea behind the cloud robotics is where you are streaming all the sensor data, all the information received by the robot in a real time, stream it to the cloud, where you can actually use like a huge computational factories, huge computers running very advanced algorithms, make a decision, and then send back just the control signals. So by doing it this way, you can really keep the actual hardware cheap and with a long battery life without really powerful computer, and still expose very complicated and advanced behavior out of it. That's why it's so interesting. That's why it's a kind of a hype nowadays. And yet another point I would like to mention that in fact building more or less serious robot is not an easy task, and that's why I would suggest, if you decide to start doing something in this domain, think about building a team out of it. It's a very interdisciplinary topic, and it's always an advance. You can't know everything, and that's why it's makes sense to build a team, or maybe join the team and then contribute to it. You will get much faster ahead than trying to do everything alone. And the last point I mentioned here, and this is really what is important for me, is I think we as a robotics builders and the community reach the point where it makes sense to start concentrating even more on solving the real life problems. For the just so pure educational purposes, it might be good to build very simple examples or try to repeat the work which already have made. But in fact, I would like to encourage those of you who decide to make something in this direction to try to solve real life problems. And when I mean real life problems, probably the first things comes to the mind is the vacuum cleaner robot, which can make the life easier. And everybody knows about them. They are in fact really simple. And I believe that we are currently at the place where we can actually try to target more advanced goals. And as an example of it, let me say a couple of words about this vehicle, about this robot. This is, by the way, very interesting. We've get to know these guys on these are two French guys. We get to know them at one of the exhibitions. There was our neighbors in the booth. And what they've made a robotics vehicle completely autonomous to cut dead branches in the wine fields. So they have several cameras mounted on it. There are also, you can see it here, but there are also kind of special cutters. And there is also solar, it's solar powered. And this vehicle driving in a fully autonomous mode, they also have a GPS on it and so on, in fully autonomous mode, automatically detect the dead vine branches and then just cut them out. And this is, to me, it was like it's a dream job, because they have their own small production facility somewhere in France. Then who are their customers? They are those ones who are making great wine. So you build a robot doing what is fun, and then you are driving to the customers, make sure that it works, and then enjoy the evening, like watching how it drive around and drinking nice wine. So this is my dream for actually. This is where I want to be also at some point of time. But seriously, I believe that this is a really great example of what I mentioned about solving real life problems. And I believe that we as a robotics community, we are already there where we can really tackle this kind of problems. Well, actually, there is also in the presentation. I assume that it probably would be available somewhere online. I also summarize all the relevant links where you can find much more information about this particular vehicle, about our current development activities and source code, examples, videos, and so on. So here, just several links about it and relevant websites.